So now we want to rewrite an equation of a circle, x squared plus y squared plus 2x minus 6y plus 7, into a format where we could identify the center and radius of a circle. And so we do know that this is an equation of a circle because there are no coefficients on x squared or y squared. We could have coefficients on x squared and y squared and still have it be the equation of a circle, so long as it was the same coefficient on both x squared and y squared. All right, so for instance, if we had 2x squared plus 2y squared, so let's just say this was the equation. You don't have to write this down. Plus 2x minus 6y plus 7 equals 0. See, notice they're the same coefficient. So I could divide every term, and it would have to be every term, by 2 there. And notice I'm back to having just x squared plus y squared. So this would be an equation of a circle as well. All right, so long as x squared and y squared don't have any coefficients on it, or they have the same coefficient. And actually, maybe we'll do one where they have the same coefficient, and we'll rewrite that one as well. All right, I have 2, though, where x squared and y squared have no coefficients on them. All right, so if this is not in the format x minus h squared plus y minus k squared equals some number, which is going to end up being the radius squared, we need to rewrite using completing the square twice. Once for x and once for y. And we can do them both at the same time. Right? But we need to rewrite it so we have, so if you remember, we rewrite just a quadratic equation using completing the square, we end up with y equals x minus h squared plus k, right? That would be the equation of a quadratic, right? So we're going to do kind of the same thing, except we're going to do this once for the x's, once for the y, and we're going to have the constant is going to be the isolated term. All right, so let's go ahead and do this one. And if you remember, we did do this in geometry. So hopefully seeing it will trigger your memory on how to do this, because I'll do 3 examples. I have 2 written in here, but I'll do 1 more with coefficients on x squared and y squared. All right, so our first step is to put the x's together and the y's together. So I'm going to write that in. So put x terms together and y terms together. And set equal to the constant, whatever the constant term is, even if that constant is 0. All right, you want to move that constant term. All right, so we've got, so I'm just going to move the x. So I've got, I'll just write the whole equation. X squared plus y squared plus 2x minus 6y plus 7 equals 0. So in other words, I'm going to just switch the order so that the 2x is next to the x squared, and the negative 6y is next to the y squared, and then we'll subtract 7 from both sides so that the constant is on the other side. So we have x squared plus 2x. I'm going to leave a space, right, because that'll save me a step. Plus y squared minus 6y, I'm going to leave another space, equals negative 7. And I don't have a whole lot of space there, so I'm going to just move this over just a tad. Or I'm going to run out of space on the other side. All right, so that's our first step. Step 2, you're going to add b divided by 2 squared for x and b divided by 2 squared for y to both sides. And because I left a space, I don't have to rewrite everything again. I'll just do it in that open space. All right, so b is 2, right, for x, and b equals -6 for y. Right? It's just the coefficient on the x term and the coefficient on the y term, the one without the exponent. So I have, oh, I'm going to add it right there. So I have 2 divided by 2 squared, just squeeze that in there, and -6 divided by 2 squared. So our goal here is to make each of these a perfect squared. The x is a perfect square and the y is a perfect square so that we can rewrite it like this. Now, if you do something to one side, you have to do it to the other. Otherwise, your equation won't balance. All right, so I'm going to have to add 2 divided by 2 squared and -6 divided by 2 squared. And we're running out of space. It's a good thing I moved things over, but I don't think I moved them far enough. That's not as clear. That this thing here, that's a -6. I could have made that a little clearer. Maybe that looks better. I don't know. All right, so let's just simplify. And I'll do that in blue. So this would be x squared plus 2x. 2 divided by 2 is 1. 1 squared is 1. Y squared minus 6y plus -6 divided by 2 is -3. -3 squared is 9. And then I have the same thing here. -7 plus 1 plus 9. All right, and so now our next step is to factor, because these are perfect squares. This is an easy factor. The factoring will always be x, whatever the sign of b is, positive or negative, b divided by 2 squared. All right? So I have x squared plus 2x plus 1. B divided by 2 is 1. And as a matter of fact, it's going to be this thing right here without the square. So I'm going to factor the x's. Right? So this part here becomes x plus 1 squared. Right? So it's just like when we were completing the square, we're just doing it twice. Right? Instead of solving for a quadratic, we're just rewriting the equation of a circle. Right? We're going to do the same thing for the y's. Right? So this one's going to be y. This one's going to be y minus, right? Because that b is negative. And half of 6 is 3. It's also the same thing that we squared. And then we can add those numbers together. All right? -7 plus 1 plus 9 is going to be 3. And we're done. That's it. All right? So 4 easy steps. They're easy once you practice them and get good at them. All right, and hopefully that'll come pretty quickly for you. We can now do the last thing, which we were asked to not only rewrite this, but to identify the center and radius. So that'll be our step 5. Because that's what we're asked to do. And we'll always do that when we're just rewriting. All right, so our center, remember the equation is x minus h. So if we see a plus, this is really x minus a -1. So our center is going to be -1. The negative goes with the equation for the y there. -1, 3 is the center. Right? So the signs are going to be the opposite because a negative is already part of the equation. The radius, we just take the square root of that constant there, right? So this 3 here represents r squared. So that means the radius is just going to be the square root of 3. And yes, it must be positive because it represents a length, and length is a positive number, right? There's no such thing as negative length, right? And that's the end of this one, right? Let's do another one. All right, I wrote all the steps here on the first one, right? I might not write the steps on the second one because they're right here, and I can pause and you can write them in if you'd like. All you need, one in your notes is fine. So let's watch 2 more examples. All right, one very similar to this one, and then another one I'll put coefficients in front. All right, and if you need me to, I'll pause in class, or you can pause if you're watching this on your own. All right, let's look at this one. X squared plus y squared plus 8x plus 4y minus 29 equals 0. All right, so we're going to, and I didn't even put directions on it, but I knew what I wanted us to do. Oh boy, this is all like in little pieces. There we go. So we're going to rewrite and identify the center and radius. And there's no way we're going to identify the center and radius when it looks like this. Let's put it in the right format. All right, so first thing we're going to do is we're going to rewrite this so that the x's are together, the y's are together, and the constant's on the other side. Right? Same as we did before. So this will be x squared plus 8x. I'm going to leave a space. Plus y squared plus 4y, and we're going to, the 29 is going to, we're going to add 29 to both sides, right, because 29 needs to go to the other side. All right, so that's step 1. And 2. Actually, I'm going to try to color code it the same way I color coded it before. All right, so then I wrote in red. And 2. All right, because now we're going to add in the b divided by 2 squared. If I leave a space, I can do that all in kind of in one step. I would just rewrite it, leave a space, rewrite your equation, leave a space, and then you can add in b divided by 2 squared. So that would be 8 divided by 2 squared, and 4 divided by 2 squared. And if you do it to one side, you got to do it to the other side. So 8 divided by 2 squared and 4 divided by 2 squared. Oh, that's a horrible looking 4. It's moderately better. All right, so now our next step is going to be to simplify. So now we have x squared plus 8x plus 8 divided by 2 is 4. 4 squared is 16. Y squared plus 4y plus 4 divided by 2 is 2. 2 squared is 4 equals 29 plus 16 plus 4. All right, so now we're going to, we can factor. So our step 4. We're going to factor the x values. We're going to factor the y. And let's just add that together. All right, so we have x, that's a plus, so that's going to be still a positive. All right, so, and then it's going to be half of b. b is 8. All right, so it's actually this value right there. 8 divided by 2 is 4. So this is x plus 4 squared plus. All right, now I'm going to do the same thing for the y's. All right, so this is y. It's also plus, and it's going to be half of b, or this value right in there that you squared. And half of 4 is 2. So this is y plus 2 squared. Equals, and that's going to add to 49. And our last step, we can identify the center. So remember that this really means x minus a negative 4 squared and y minus a negative 2 squared. So our center, move that down just a little bit. Nope, no, I guess I can't. They're connected. Our center is going to be negative 4, negative 2. And since we didn't have a nice whole number, integer value for the radius, I thought I'd make it a pretty number on this one. The radius is going to be the square root of 49, which is just 7. Right? And that's all there is to this one. I'll do one more. What if we had coefficients? So we're going to rewrite and identify the center and radius. And I could give, I've been trying to keep the numbers kind of friendly. So I've given us all numbers that would end up being even, because it's much easier to, take half of an even number. All right, and this one I'm just writing on the top of my head. So 3x squared plus 12x, oops, I'll put it in standard form, plus 3y squared, or not standard form, excuse me, I'll put the squared terms and then the x's, so we have to rewrite it first, plus 12x, actually let's do minus 12x, minus 36y, and then I'll keep it so that it divides evenly by 3. And then minus 27 equals 0. All right, there we go. All right, so here, notice that there's a coefficient. So if the coefficient on x squared and y squared is not 1, divide by the coefficient first. Now you might wonder, what happens if the coefficient on x squared and y squared is not the same? If it's not the same, then this is not a circle. This is something else. This would be an ellipse, right? Because you're going to have a different length for the diameter going horizontal and vertical if the coefficient on x squared and y squared is not exactly the same. So we'll look at that in a later time. So you will only see right now coefficients that are the same on x squared and y squared because we're talking about circles. All right, so our first step is going to be to divide everything by 3. I don't even put that in. Divide by 3. And I was kind. I made these all divisible by 3. 3x squared plus 3y squared minus 12x minus 36y minus 27 equals 0. And we'll divide everything by 3. So we have x squared plus y squared minus 4x minus 9, since when is 36 divided by 3? 9. Minus 12y minus 9 equals 0. And I even kept it even. All right, so now we're going to do the exact same steps as we did before. All right, so step 1, let's put the x's together, the y's together, and add 9 to both sides. So that we have x squared minus 4x, we'll leave a space, plus y squared minus 12y, we'll leave a space for the y's, equals 9. And then step 2 is going to be right next to it. We'll add negative 4 divided by 2 squared, and negative 12 divided by 2 squared, and we'll add that to both sides. All right, and then step 3, we'll simplify so that we have x squared minus 4x Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. 9 plus 4 plus 36. Oh wow, that's just a coincidence. We're going to get the exact same. I didn't think we would have a radius that was going to be an integer value. Not only is it an integer value, it's the exact same integer we got before. All right, no problem. That's just kind of interesting. Step number 4, because I just wrote this off the top of my head. Step number 4, we're going to factor. So this would be x, and then that's negative, so that's x minus 2 squared. And then we're going to factor, we factored the x, the x's, went too far. So we factor the x part. Now let's factor the y part. And we can add this all together, which is 49. All right, so that's going to be y minus, because b is negative, half of b is 6. It's the same thing as you squared. So y minus 6 squared equals 49. And now we'll identify the center and the radius. So the center, whenever the negative goes with the equation, the center is 2, 6. And the radius is the square root of 49, which is again 7. How about that? Got the same radius twice. All right, so that's all there is to writing the equation of a circle when it is not in our nice standard form where we can identify the center and radius. We just use completing the square twice. One's for the x's, one's for the y's. Don't forget to add to the other side. Right? And once you rewrite it using completing the square, you have the x-coordinate and y-coordinate of your center. Take the square root of the constant, you have the radius. Right? That's all there is. Thanks for watching. Bye for now.